Alright, so to wrap up this week with our geometry, we're going to look at the part 3 of 3 videos which we started 2 days ago on relationship of linear equation, and today we're looking at lines of concurrency or points of intersection. So we looked at 2 days ago how to identify and find parallel linear equations. That was our part 1. Then our part 2, we look at how to identify and find perpendicular linear equations. And now today our part 3, we will look at how to identify and find concurrent linear equation. Just as a quick recap, remember for the first one, when we look at parallel lines, we just say once the gradients are the same. So M1 is equal to M2. In the second one, we look at the gradients again, perpendicular, but in that case, M1 multiplied by M2 supposed to give -1. So today is the only one that we will not be focusing on the gradient because it has nothing to do with the gradient actually, although the gradient could help too, but here we're looking at coordinate points and you will see what I mean. So concurrent lines or intersecting lines are basically when two lines are said to be concurrent if they intersect. Good. And secondly, to find out if two lines are concurrent, all you have to do is solve the linear equation simultaneously, or you can substitute one equation into the other one and then solve for x and then y, or y and then x. And this is the method I'm going to be using today. Since simultaneous equation is a specific skill set or technique that you need to know, and I don't want to teach it here, I want to do that later. But if you already know how to do it, then that's how you go about determining if two lines are intersecting. Once they intersect, that means you will find an x or a y value. If they're not intersecting, then there will be no value for either x or y since they're not intersecting. So in short, you set both equations equal to each other, and that's the easiest way. That's what we're going to do today. Good. So here we have an example. We have two lines. I could solve it simultaneously, but I would not. I will use the second method. And the second method simply means that you just take one of the equations and you plug it into the other equations. And that's a lot easier said than done, but let me just do it so that you would understand. So I will write the two equations first. So we know that one equation is y is equal to 7 minus x. And we know that the other equation is y is equal to minus 2x plus 10. So notice this. Y is equal to 7 minus x. Y is equal to minus 2x plus 7. So I could take one of these y's, I could take this y if I want and put it for this y here, because that is what y is. And if two lines are intersecting, this is the scenario. If two lines are intersecting, that means at this point, imagine this is on a coordinate plane. So we have our y and we have our x. At this point, the two lines will have the same x and y coordinate. So that's all we're basically trying to find. Once the lines are intersecting, that means that they have a common point of intersection, an x value and a y value. So if they're intersecting, it means that at this point, these two lines are equal to each other at this point. So that is why we just set one of the equations equal to the other one, and that way we could find if there is an x or a y value that corresponds. So let's do that now. So the easiest way for me, look at this, look at what I'm doing here. So we have, and then of course we have to find the subtractive formula. So we have y is equal to 7x plus 3. So this is my situation here. 7 minus x is equal to minus 2x plus 10. That's all I have to do. And then I just solve for x. And you may ask, okay, how did this come about? Look at it. This here was y. So remember here, look at it here. We had y is equal to minus 2x plus 10. Y is equal minus 2x plus 10. And we also said y over here is equal to 7 minus x. So all I did now, I took a y and I just wrote the other equation. In this way, I am setting them equal to each other. And once I do this, I could find x now. All I have to do is make x the subject of the formula. And once I know what is x, I could easily know what is y, because I just have to resubstitute. So let's find x here now. Let's see, to find x, the easiest way here, transposition again, we're making x the subject of the formula. So I'm sending the negative 2x on the other side, and I'm sending the 7 on the other side. This negative 2x is negative. So when I send it over, it will be positive. So that means on this side, I will have 2x minus x is equal to, this 7 is positive. Remember, if there's no sign in front, it is positive. So when I send him on the other side, it will become negative. So that would be negative 7 plus 10. 2x minus x, that will give me just x. Think of this as 2 apples minus 1 apple. That will just give me 1 apple, 1 apple. But there's no need to put the 1 there. And that's equal to minus 7 plus 10, that's actually positive 3. Take away the smaller from the bigger, but you keep the sign of the bigger one. So that's positive 3. So x is equal to 3. Easy does it. And if I know what is x, I could easily know what is y. I could plug it in either equation above. I could use this one if I want, or I could use this one if I want. I will use the easier one, of course. So if x is equal to 3, then y will be equal to 7 minus x. But remember, we know what is x. X is 3. So that will be 7 minus 3, which will give us 4. So y is equal to 4. Easy does it. So that's all there is to it. So that means that in this line, when x is 3 and y is 4, there will be an intersection. How do I know that? Because it's question solved to get that. If it wasn't possible to get an intersection, then that means this here would not be solved. It wouldn't work out. There was just something would happen that it wouldn't give you an x or it wouldn't give you a y. Good? And basically that's all there is to it. That's all there is to it. So for instance, let me just draw the sketch again. So I know that x was what? X is 3. So 3 would be here, and 4 for y would be somewhere here. So you see at this point here, we will have an intersection taking place. So I know this line because the gradient is negative. I know that this line is equal to negative 2x plus 10. And this line here, because it's positive, I would have 7. No, actually both lines are negative. Both lines are negative. So this line would actually run something like this. Yes, it will run. Both lines are negative. So this line would actually run like that. And this line here would actually be y is equal to 7 minus x. Good? But at this point, we have concurrency. At when x is equal to 3 and when y is equal to 4, these two lines will intersect each other. Good? Graphically speaking. Whew. Tough work. But yes, that is how it goes. Let's do the second one. Let's do another example and see. This is supposed to be a y, not a 9 or a g. It looks like a g. Good. And x here. Let's go. Next one. Here it asks us to show that the line 3x plus y is equal to 18 and the line 2x minus y is equal to 7 are intersecting. Okay, good. So again, to prove that they are intersecting, once we solve one for the other, we're supposed to get a value for x and a value for y. But notice how both equations are written. And once an equation is written like this, well, you don't have to, unless you're really good, but it's better to always rearrange it into the general form of the equation. So okay, let me do that quickly. So we have 3x plus y is equal to 18. But I prefer to isolate the y, so that will give me y is equal to minus 3x plus 18. So now this here is written in the general form as in y is equal to mx plus c, right? Y, m, c, or x with x. Good. And let's do the same thing for the other equation. The other equation, we have 2x minus y is equal to 7. And let's see, okay, the y is negative, so the y has to be positive. So I send over the y over here, and then I send over the 7 over here. So that would be y is equal to 2x minus 7. I actually send it over and I rearrange it at the same time. But again, at this point, we're supposed to be able to understand what is happening there. So yes, so that's the situation here. And now, all I need to do is set one equation into the other one. So I will set what? I will set this one here. I will send this one here over here for y. So I'll just substitute y for what I have inside here. So to solve this now, I have, and mind that this could be done for x too. If you want, you could make x the subject, and then whatever you get for x, you just substitute it on the other side. And this is, I would say, a shortcut to avoid simultaneous equation. Although simultaneous equation is rather straightforward too, but I'm just sharing options here with you, right? So if I do that, I will have now my new equation, or my reference equation would be 2x minus 7 will be equal to minus 3x plus 18. Good. So all I did is I put in y here because y is y. So I'll just make y is equal, basically. And from here, I solve for x. And once I get what is x, I could get what is y. So here I send my x on the other side. The aim here is to put all the x's together. And then I send my 7 on the other side here. So that will leave me with 2x plus 3x. And that will be equal to, remember, this 7 is negative. So when I send him over, it will be positive. So it will be 7 plus 18. And here, 2x plus 5x, 2 lines plus 3 lines will be 5 lines. And 7 plus 18, my math serves me well, that's 25. Then I divide by 5. 5 cancel 5. What I do on one side, I do on the other. And that means that x is equal to 5. Because 5 could go into itself once, and 5 could go into 25 5 times. So x is equal to 5. And once you know what is x, you could get y. Let's use this equation here because it's a lot easier to work out. Although it doesn't matter which one you choose, you have to be the same. So y, so we know that x is equal to 5, right? So y is equal to 2x minus 7. But remember, we know what is x. So y is equal to 2 times 5 minus 7. And that will be equal to what? 2 times 5 is 10. And that would be 10 minus 7. So 10 minus 7 would be 3. And again, it doesn't matter which equation you use. Even if you use the other one, it will end up being the same thing. You could try it quickly. So right here, for example, I know, okay, here, x is 5. This equation over here. So minus 3 times 5 is minus 15. And minus 15 plus 18 will also give me positive 3. Right? So these two lines are intersecting when x is 5. Yes, when x is 5, let me write that over. These two lines are intersecting when x is 5 and when y is 3. So if you go to draw that, you would notice that at this point, you would have an intersection taking place, meaning that the two lines would have the same point, or they both will be passing through this point, forming an x at 5 and 3. And another thing you should note, this is also helpful to determine It could help you to determine perpendicular, but it's not the easiest thing to do. It's always easier to just multiply the gradients and see that you get -1. But one of the questions you could get is to prove whether the lines are intersecting and perpendicular, or if it's just intersecting but not necessarily perpendicular. Because remember, a perpendicular line is also an intersecting line. If you didn't notice, the only difference is that when you have a perpendicular, they intersect at 90 degrees. But that's not the only way you could intersect. You could intersect without forming a 90-degree angle, naturally, right? So that should bring us to the end of today. Like, share, subscribe, comment, turn on notifications, and until then, you enjoy your weekend. Bye-bye.